Hi students, the eighth sum in the dual nature of radiation. When a 6000 angstrom unit light falls on the cathode of a photocell, photoemission takes place. If a potential of 0.8 volt is required to stop the emission of electron, then determine the following quantities. 5 quantities are asked. So the first one is frequency of the light. Second, energy of the incident photon. Third, work function of the cathode. Fourth, threshold frequency. And fifth is the net energy of the electron after it leaves the surface. So let us try to do one by one. Before that, what are all the given quantities? Let us write now. Okay. So what is given here is the incident wavelength of light is 6000 angstrom unit. So this is equal to 6 into 10 to the power of minus 7 meter. Then 0.8 volt is applied to stop the electrons. So the stopping potential V0. This is equal to 0.8 volt. Now, if you multiply this stopping potential with the charge of the electron, then E into V0. This is equal to what? The kinetic energy maximum. That is equal to what? 0.8 electron volt. So this is for our reference. We can note it first itself. Okay. Now what is the first subdivision? Okay. Let us consider the first one, the frequency of the light. Okay, lambda is given nu, the frequency is nu. Okay, so frequency nu is equal to C by lambda. Direct substitution. C is the velocity of light, lambda is the wavelength of light. Therefore, frequency is equal to 3 into 10 power 8 divided by 6 into 10 to the power of minus 7. So 3 by 6 is what? 1 by 2. 1 by 2 is 0.5 into, now this 10 power 8 is multiplied by 10 power plus 7. So this is 10 power 15. Therefore now the frequency is equal to 0.5 into 10 power 15 or 5 into 10 power 14 hertz. So this is the required answer for the first subdivision, namely the frequency of the incident light. Okay. What next is the second one is what? Energy of the incident photon. So energy is denoted by E. Okay. So capital E is equal to what? H into nu. So nu just now we have found. H is the Planck's constant. We have to multiply. Therefore, E is equal to H into nu. 6.626 into 10 to the power of minus 34 multiplied by 5 into 10 to the power of 14. The answer is in joule, SI unit. Okay. So this is also equal to 6.626 into 10 power minus 34 into 5 into 10 to the power of minus 14 whole divided by the charge of the electron 1.6 into 10 power minus 19. If you divide joule by the charge, then now the unit will become what? Electron volt. So let us now find out the calculated value of this. So 6.626 multiplied by 5. So that is 33. So this is equal to 33.13 divided by 1.6 into, now adjust the 10 powers. So this minus 19 will go up. Okay. So this is 10 power plus 14. This 10 power minus 19 goes to the numerator as plus 19. So plus 19 into 10 power 14. So this is 19, 29, 33. So this is 10 power minus 34 into 10 to the power of this is 33. The unit is electron volt. Okay, now let us divide 33.13 by 1.6. So divided by 1.6. So this is equal to 20.7. Therefore, we get the energy is equal to 20.7 into 10 power minus 1. So into 10 power minus 1. Therefore, E is equal to 2.07 electron volt. Let us convert joule into electron volt, because in the next subsequent parts we are supposed to convert this into electron volt. So now itself we have converted it into electron volt. What next is the work function of the cathode. Okay, that is the minimum energy required for liberating the electron. So the third subdivision. So work function. What is the symbol for work function we have used is phi naught. Okay, phi naught. So this phi naught is equal to H into nu naught. Okay. From Einstein's photoelectric equation, this is also equal to H nu minus kinetic energy maximum. Just now we have found E is equal to H nu, is it not? The energy E is equal to H nu, we have found 2.07 electron volt. So instead of H nu, what we can substitute now is 2. So this is 2.07 electron volt minus kinetic energy maximum, already it is given here, 0.8 electron volt. So 0.8. So the answer is in electron volt. So the difference between these two, 2.07 minus 0.8. So this is equal to 1.27. Therefore, phi naught, the work function, is equal to 1.27 electron volt. So this is the required answer. Okay, what next is the fourth one? The threshold frequency. Threshold frequency is nu naught. In this symbol, nu naught. So the same formula I am going to use now. Okay. So the fourth subdivision is threshold frequency. Threshold frequency nu naught. So phi naught is equal to H into nu naught. H into nu naught is equal to how much? We have got 1.27 electron volt. So H into nu naught. That is nothing but the work function only. So phi naught, in place of phi naught, I have substituted H into nu naught. And the answer is in the electron volt. So this is 1.27 electron volt. So 1 electron volt is electronic charge of that is a charge of electron times joule, is it not? So I am going to convert this electron volt into joule. So this is 1.27 into 1.6 into 10 to the power of minus 19 joule. Why? Because the left hand side Planck's constant is in SI unit only, we know it, isn't it? So if you substitute the frequency will be coming in SI unit. That is why I want to convert electron volt into joule. Therefore now nu naught, okay, nu naught is equal to 1.27 into 1.6 into 10 to the power of minus 19 divided by H is the Planck's constant, we know it, we must know. So 6.626 into 10 to the power of minus 34. So what is this? Let us find out. Now 1.27 into 1.6. Okay. So this product is 2.032 divided by, so this is divided by 6.626. So this is equal to 0.3066. Okay, 3066. This product into, now 10 power minus 34 will come to the numerator as plus 34, is it not? So 34 minus 19 is 10 power 15. 10 power 15. So we can adjust the decimals so that nu naught is equal to 3.0 or 3.066 into 10 power 14 hertz. This is the usual practice of expressing the frequency as 10 power 14 hertz. Okay, so one decimal digit, 3.1 also we can write because rounded off value is 3.1 only. So 3.066 into 10 power 14 hertz, that is the threshold frequency. Now what next we have to find? Lastly, the net energy of the electron. Net energy of the electron after it is emitted from the surface. So what is the minimum energy required to liberate the electron from the atom is called work function. So if there is no loss of energy due to collision, the electron will come out with maximum kinetic energy. That only is asked in the fifth subdivision. So the fifth subdivision, kinetic energy maximum. So that is equal to charge of the electron into stopping potential. So this is a charge of the electron into stopping potential. Directly we can write. So electronic charge into 0.8 volt. So 0.8, this is electron volt. Therefore, Ke maximum. Okay, is 0.8 electron volt. So this problem looks like a very lengthy problem, and it is easy only. Only thing is, sometimes we will have to express the energy in joule and sometimes we have to convert it into electron volt. So be careful while the conversion of the unit from joule to electron volt. Otherwise this problem is very easy. I hope you must have understood well. Fine.